Hello guys, welcome back to our small tutorial. So here we're going to look under the course CPE 305 and we're going to go through the topic binary multiplication. So it isn't a big deal to make the calculation because it's just something straightforward, and the multiplication is done just the way normal mathematics multiplication is done. So before we begin, let's look at 2 or 3 rules, or let me say 2, before making this multiplication. It's all well known to us that 0 multiplied by 1 is 0, and 1 multiplied by 0 is 0. 1 multiplied by 1 is 1. Yeah, so that's okay. I think these are the 3 sayings we can encounter during the calculation. So sharply, let's move on to our solution. First thing, write solution. Okay, it says multiply. Okay, given that a is equal to 0 0 0 1 1 1 1 and b is equal to 0 0 0 0 1 1 0 1, then multiply a and b. Alright, what we're going to do is just to arrange them in an order of multiplication. How? Look at it. 0 0 0 0 1 1 1 1. This is a multiplied by, okay, it's formally begin here. Okay. 1 0 1 1 0 0 0 0. Okay, this is the order of multiplication. So before I start, let me introduce something. It isn't new, but maybe the way people took it is different from the way it is. After multiplying these two numbers, we have some certain values obtained here. So we use a method called the partial addition in terms of obtaining the final answer. So it did the same here also. We use the partial addition after making the multiplication between these two numbers to obtain our answers. Let's go and see what will be yielded. Okay, you know that 1 by 1 is 1, and 1 times 1 is 1. So this is telling us that the entire of this will be repeated here because all the numbers will be multiplied by 1 individually. So 1 times 1 is 1, 1, 1, 1 times 1, 1 times 1, 1 times 1 times 1 give us this, and 1 times 0, 0, 0, 0, 0. So we'll now move to the second significant, which is 0 times 1, 0 times 1, 0 times 1. And any number multiplied by 0 is 0. Any number multiplied by 0 is 0. It is implies here. Alright, now let's say 0 shows that all of the values here will be equal to 0, like this. So the next thing is to say 1 multiplied by this, 1 by this, 1 by this, which is this one. So it's going to multiply everything here by 1 and we'll obtain the same value right here. Then we begin here, which is 1 1 1 1 0 0 0 0. The next one also, it is 1 here, so we'll obtain 1 1 1 0 0 0. Oh, mistake. This one should be 1. 0 0 0 0, and what we're having here are all 0, so we're just going to neglect them, because if 0 comes before a number, it doesn't change the magnitude of that number. So from here, these are the values we obtained by multiplying these two numbers. In order to get the final answer, we undergo what is called the partial addition. The partial addition normally takes place of this particular layer of origin. So what I'm to do, I'm to draw a line like this. Okay, since we are dealing with binary, it will be very advisable to create a layer like this that will obtain all the carries. Normally there is something you're expecting. For example, you multiply two numbers like this, like 1 by 1, it will give me 1 0. So I'm to keep 1, and this 1 will be a carry. So that's why it is advisable to leave this space in order to indicate all the carries with their respective orders. But before I continue, there is something very important we call padding. So in order to make this look very good, let's pad here. Let's pad with zeros because it will change nothing. And let's pad here also with zeros because it will look good and it will change nothing. Okay, so in this particular layer, we're going to perform the partial addition. So it's just normal binary addition, but there are some significance of that have to be known. So it's a 1 plus 0 plus 0 plus 0 here is. So don't write the 1 here. Come here like some specification and write 1. Okay? The same thing, 1 plus 0 plus 0 plus 0 is the same thing. 1. Okay? But here we have a distinct of the 2, which is 1 plus 1. And we normally know that 1 plus 1 is 2. And in binary equivalent, 2 is represented as 1 0, which is we have to keep 0 here and carry 1 to the next column. But there is a concept here. For example, I'm having like 3 columns, which is 1 2 3, like this, 3. Okay, so this column each represent a set of binary number, So assuming we multiplied a number like this 2, for example, from the set of binary obtained here. For example, let me say 1 1 1 1, okay, 1 1, like this. Assuming we have a set of binary in each column like this. So if we make the partial addition here, we know that this 1 plus 1 is 2, and normally 2 is represented as 1 0. So keep the 0 here, bring the 1 here. Okay, if you add this, yes, it's 1 plus 1 plus 1, and it is 3, and my 3 is represented as 1 1. So keep 1 here, add the 1 to the next column. Okay, what if I have 4 here? By 4 is represented as 1 0 0. Okay, if for example it is this one, let me make a boundary to make it more clear. If it is 4, which is 1 plus 1 plus 1 plus 1 is 4, it is 1 0 0 4, right? Okay, keep the 0 here, keep another 0 here, then keep 1 here. So we call such the second order. The previous one we did is the first order, while the second one is the second order. Why is it first order? Because it is in the column immediately after the column that the operation was done. It is second order because it is 2 steps, okay, after the column in which the operation is done. Let's see it here. It will be very clear and comprehensive, inshallah. So this one we have 1 plus 1, and my 1 plus 1 normally is being on 1 0, so I will have like 0 here and carry of 1, but the carry this time around will be situated here and indicated as the first order carry. Okay, so if I add this 1 plus 1 plus 1 plus the carry here 1, which is 4. You know 4 is normally 1 0 0, 1 0 0 is 4. This time around the carry will not be immediately after this column, but after again, in order to situate all these digits. Look at it. I'll say 0 here, another 0 here. You know it is 0, it will change nothing. Had it been it is not 0, then I will indicate it, but it is 0, it will change nothing. Then bring the 1 here as what? Second order this time on, because it leaves 1 2 first second, so it will be somewhere here. Oh my god, let me use the blue pen. So it will be here, so indicate it as second order carry. Okay, and here if I add this 1 1 1 plus 1, it is 2, and my 2 is 1 0, so it will be 0. Since it is 1 0 0 here, 1 will be situated here, but how? As a first carry order, so indicate it in the top one. The first row obtain the first carry, the second row the second carry. We did all this in order to make our work look very clean and beautiful. And this one also, it has 1 plus 1 plus 1 plus 1, which is 4. So we have 0 here, another 0 here, and 1 here as second carry, which is to be situated here. Okay, so we add this, we obtain 1. How? 0 plus 0 plus 0 plus 0, which is 1. Okay, so we add this one again, 0 plus 0 plus 0 plus 0 plus this one, we obtain 1 also, and all these are zeros. 0 0 0. So our final answer here will be 1 1 0 0 0 0 1 1 page 2. Thanks for watching. For any suggestion and more explanation, please leave a comment below, and I beg to subscribe this channel, please. Thank you.